So basically execution options for machine and deep learning software. So my plan was basically to do that after the break, but we can also do that before the break, and we have a little bit more time on exercises. So basically, when you're working on our cluster infrastructure, or in general as well, also if you're on your notebook, for example, or on the computer at home, there are typically multiple ways how to execute stuff. Most of the machine and deep learning software is Python-based, and here we have two options. So containers, this is what we recommend on our cluster because it has certain pros. And the other direction is virtual environments. So containers is basically a virtualized operating system, holds, so the different images have then basically pre-installed software that you can use. And under the hood, it uses some kernel mechanisms from the operating system you are running on. We also, on our cluster, have predefined containers. I will come to that in a second. The big advantage, especially if you're working in teams, is reproducibility. So basically, it can be used by all users on the cluster, also team members. You always have the same environment. You don't have different environments because if you, for example, use virtual environments, you have a very unique installation. And one sentence that often pops up is, but it works on my installation or on my machine. And that is pretty good, but it does not help your colleagues. So basically, this is a first step into reproducibility. So you have the same environment for your different team members. You have the same environment for development and testing. So basically a fixed software stack and environment. Another thing that is pretty good on our system is we have less pressure on the file systems. And the background here is if you install virtual environments by hand, every user has its own environment, and this consists of millions of files, sometimes 100,000 or millions of files, several gigabytes, and let's say we have, 20,000 users and everyone installs a virtual environment. We have a lot of stuff in the file system that could be saved. It gets slower if everyone does that. So basically we have less pressure on the file system because we only have one copy that can be used by all users. Good. Approach 2 is virtual environments. So there are different solutions available. We have typically something with Python virtual environments that is available out of the box. So basically a pip package manager. Conda and Anaconda. So this an older slide. Anaconda is not allowed to use on our servers anymore because of some restructuring of the user. How's it called? So it's kind of license problem. So basically there are free alternatives like Conda Forge. It's basically also a Conda environment, but does not internally use the Anaconda repositories, but the Forge repositories. So basically Conda is still possible, but not with Anaconda under the hood. Can also be used on your desktop, so it's pretty easy to set up. And if you're working alone, that's fine. If you need some reproducibility and work with other people, probably the container part is a better solution for you. So virtual environments have high flexibility. You can install packages, update packages as you want. So this is not the ones built. They can be modified anymore because you can modify it all the time. The big disadvantage is every user has its own installation, and sometimes also if you say, okay, team member 1, please install that environment in that fashion, and then probably the versions of different packages also is different. So it's not always a one-to-one comparison. And a lot of files on the file system. That is basically our operational view. So if everyone has multiple virtual environments, that gets really tricky with performance sometimes. Okay, here's some short information about containers. How do they work? So typically we have the bare metal, the host machine. We have an operating system on our cluster that is a Linux distribution. So here we have Rocky Linux. We have a container engine, and typically Docker. We have Aptainer, because we are not allowed to execute Docker because of security reasons. So container engine here in our case is Aptainer. So basically on the operational side, you have applications that directly use software that is installed on our systems, like for example, the module system on our cluster. But you can also use containers, and the idea here is basically these encapsulate a virtual operating system, some software, so basically predefined containers, and you can run applications within that container and that share some hardware or kernel features from the original operating systems to be able to execute it on the host machine. So this is basically a rough sketch how containers work. There are different container engines out there. Docker is typically what you will use on your local system. There's also something called Shifter that is active in the HPC sector. Some facilities use that. We use Aptainer, like many others. Good. Did I put that on this slide? Yeah, kind of. Yeah, so you can also basically build container on your machine, but also now on our system. So you can create predefined containers for yourself. You can also convert Docker into Aptainer. Yeah? So if you have some Docker image somewhere in Docker Hub, and you say, this is the stuff that I want to use, you can go, there are some predefined scripts on the Aptainer documentation, how to convert a Docker container into Aptainer, and then you can run it on our systems. All right. I don't see any questions. If there are questions, just interrupt me, raise your hand. Otherwise, I continue. So we have predefined containers, and here's just a sketch. So the slide is also a little bit older. There will be new containers for PyTorch and TensorFlow soon. So this is probably roughly a year or half a year old. As I said, we typically focus on the software that is mostly used to provide central images, like PyTorch and TensorFlow are pretty popular. And we have one that is called Data Science Notebook that basically encapsulates multiple Python packages like scikit-learn, data preprocessing, data science packages that you need for your workflow. So the question is now which image to use. In principle, I would like to have an image where everything is installed. But that's sometimes a little bit tricky because of dependencies. So for example, if you want to do some pre-processing, it might be that you need this notebook, this data science notebook container, and later on you want to do some PyTorch. So here the question is really, it's basically a separation of concerns. For example, in your workflow, you can use one container for one workflow step and another container for a different workflow step. Otherwise, if you really need one container with more images, I will come to that in a second, how to basically solve the problem of missing packages. Good, as I said, we have Aptainer. I also linked the documentation for Aptainer based on Docker images, and we also support user containers. If you have any particular container where you say, okay, this is a container that we really need on our system, that a large community is able to use, just pop us a mail and we will basically look at that and then provide a standard container for everybody. Okay, good. So how to handle missing packages? Containers are read-only after they are built. And what happens if a package is missing? For example, here I have a short sample code which uses matplotlib. And I used the TensorFlow container, and matplotlib is not, I think it is not available in that container when I did the tests. So I basically said, okay, I want to create a shell, open that image, and I get a shell inside the container, and I execute that script, and then bang. So import matplotlib does not work, module not found. That's bad. How do I solve that? So either I create a different container and add that, but there are also some workarounds or hacks. What I can basically do is, first of all, clear separation of concerns, like I said, different containers for different tasks. Other workaround is basically make additional packages available to the container. For example, I could basically install matplotlib in my user space and then make that available to the container. For example, by extending the Python path within the container. I have to basically check that the Python versions are the same, but in principle that works. Here, same basically. I'm currently in the container, and when I'm in the container, I can basically do a pip install -- user matplotlib, and then it will install matplotlib not within the container, but within my user space, matching to the same Python version that is used in the container. Good. I think from the time point of view, we are right on time for the lunch break. I have some backup slides which tell you a little bit more about Docker, Aptainer, some scripts for virtual environments, but this is all online in the PDF. So if you want to have a look at that, feel free. Here I also said Conda Forge, Anaconda is not allowed and blocked. So there are some firewall rules in our infrastructure that prevent us from running into that license problem. But this is, I think, nothing that we need to discuss right now. These are just some examples how to use virtual environments, but you can also find those stuff online.